Fire this up. Take a peek ski. Excellent, excellent. Okay, so E9. Okay, get on here. Let's see what we got here. E9. Games are called statistically fair if their expectations are equal to 0. I mentioned this in class on Wednesday, talking about how Vegas has to keep an eye on the break-even point. You guys ran a couple of that in-class quiz, which I haven't gotten back yet from Amber. I'll get them back to you guys as soon as I do. That in-class quiz was cool because you looked at that lottery game in New York, where when it was set up properly, you would lose 40 cents per game, but when they doubled the bets, you ended up gaining 20 cents per game. Somewhere between those two, there was a break-even point where neither the player nor New York State won any money. So the player doesn't lose any money, New York State doesn't lose any money, and that's the break-even point. And that's the definition of statistically fair, with the expectation is that the average is equal to 0. So instead, refer back to the distribution from Chuck-a-Luck that we used in class and adjust the payout for a roll of 3 5s so the game is statistically fair. Awesome, awesome. I'm going to need your help on this one because I need that distribution of probabilities from class because I use the random simulator to generate those probabilities, and every class is a little bit different. So I want to make sure that I match your guys' distribution. So for Chuck-a-Luck, this is E9. We were betting on 5, I believe. I think we're betting on the number 5 playing the game. So I'm going to put that over. I'm going to put that over here because we don't actually need that number, except to keep track of what payout is which. So we'll put bet on 5. Bet on 5. Okay, so we're going to say we roll this many 5s. So you can either run none, 1, 2, or 3 out of the 3 dice. You have 3 dice, rolling them. You're either going to get none, 1, 2, or 3 dice. I tried very hard. I was at Lincoln City Friday night watching Tesla, and it was in a casino. And I tried so hard to take a picture. I wanted to use one of the one-armed bandits for your exam this week, and I took the camera out. The security was like, "Sir, put the camera away." I'm like, "I want to take a picture of the top." Put the camera away. I'm like, "All right, dude, whatever." So, unfortunately, I couldn't get a live picture of the one-armed bandit for your guys' exam on Wednesday, so I had to rely on the old data that I had.
In California, they even didn't allow me to take pictures of
I
stores.
I know.
And I wanted for my students.
It's just the way it is.
I know.
So anyway, the payout originally, if you bet on 5s and don't get any, you basically just lose your ante. So you don't win anything, and essentially you actually lose $1. This is in dollars. If you get 1 5, remember how much money you made if you got 1 5? You cleared 0 because you won $1 back. So if you bet $1 to play and won $1 back, you break even. Now that's not the same as breaking even in the entire on average. No, because what we're talking about is the average of the distribution has to be 0, not just this game, not just one game, but on average. They all want the average of the game to be 0. For 2 dice, we cleared $1 because we earned 2. And for 3 dice, we earned $9 back. Because they pay us 10 to 1 odds, but you bet $1, you give you 10, you clear 9. Here's where I need your guys. What are these probabilities from class? You guys still have those written down? Haley, you got them?
0.580.
Awesome.
0.343.
Awesome.
0.073.
Yes.
And 0.005.
And whatever's left. Awesome. Now, did you notice, friends? I was hoping somebody was going to catch this, but you didn't quite get it. That's okay, because there was a lot going on that day. What does this sum to?
Negative 46 cents.
Oh, hold that thought.
Oh.
What is this column right here?
Oh, just that. Oh, sorry.
1, yes.
I don't
That's
know.
what I thought. Oh, okay.
It's a little bit more.
But anyway.
Why? And this is not a statistical reason.
Because we just, what is it?
What is this mathematically?
Yeah.
We rounded. It's ish. Those are all ish values. These are all ish values. They're ish values. They're kind of double-ish, if you will. They're double-ish because number one, the values themselves are simulated, which is an ish. And number 2, we truncated the values down to 3 decimals. And that happens sometimes. They won't sum to exactly 1. But that is essentially 1. If you use any kind of rounding like the hundreds place or tens place or even just whole numbers place, it sums to 1. So that can happen with simulations. It doesn't have to sum to exactly 1. Now, if it sums to something like 0.972, I'd be nervous. Like 0.972 is getting too far away from 100%. Or if it was like 1.23, 123%, I'd be like, okay, I'm doing something wrong in there. I'm double counting somewhere. But 1.001 is totally fine, totally down with that. Awesome. Now, Haley, thank you. What you just gave us was the average of this game right here, based on this distribution. The average, and I'm gonna link these two different ways. The average of a payout of 10 to 1 on 3 5s. Okay, see if that makes sense. That's assuming we're getting a 10 to 1 payout right here. This is what I'm going to ask you to mess with in E9 right here. This guy right here. You're messing with this guy. So if you're messing with the payout of 10 to 1 on 3 5s, what was the average of this entire thing? You said it earlier?
Negative 46 cents.
Yep. It was negative 46 cents, which essentially means you're going to lose about $0.50 every time you play. And you can see why. The lion's share of what's happening in this distribution is happening right here. 92% of the time. 92% of the time, you're either not rolling any 5s or you're rolling 1 5. When you roll the 5, you win your dollar back. When you don't, you lose your dollar.
Yep.
So essentially, there's where your negative 50 cents is coming from. Now, some of you are going to say, Rule, that's not quite right, and you're correct, because this happens less than this. So technically speaking, it should be more negative, because that's more likely, but that's where these guys kick in. These guys kick in and make up that difference. Because you do get this, you get this 7% of the time. That's not horrible. Every 100 games, you're going to get 2 5s on average, 7 of those 100 games. Okay? This one happens very rare. This one happens it's very rare. We actually saw that as we held out F9 on Wednesday. Good. But the question in E9, the question is we have to adjust the payout on 3 5s.
Instead of 2 minus 46 should be 0.
Yes, exactly. What we want to do, let me make sure I can see this okay. Yeah,
Adjust it for what?
adjust it to something. That's the question is. What are we adjusting it to? So the question, we have to pretend that we are now in Vegas in the casino. We're the pit boss. Actually, we're not the pit boss. We're the people up top that you can't see behind two-way mirrors watching everything, saying, yo, table 17's hitting too much. But in order to know that table 17's hitting too much, you have to know what they're averaging as far as wins go. You have to make sure that you're bringing in 46 cents per game for the casino. Got to keep those lights on all night. Got to keep the drinks flowing freely to the patrons, keep them drunk and gambling. So the question now is, what should go there in order to make the average of the new payout for 3 5s equal to 0? That's what we want. We don't want it negative. We don't want it negative. We want it to be equal to 0. We also don't want it positive. If we make it positive, then the people that are playing are winning too frequently. We don't want that either. Well, the player does, obviously. The player wants that. But the casino wants to know where their break-even point is in order to know how to do this. So what we're going to do is we're going to walk over here, take this out, and replace it with a question mark. Let's go with a gut first of all. Is it going to have to be more or less than a 10 to 1 payout? Let's see hands on this one. In order to make the average positive, is that going to have to be more or less than a 10 to 1 payout? Raise your hand when you got to vote. In order to bring the average up to 0, that's a good hint right there. Bring the average up to 0. Is the payout for 3 5s going to have to be more or less? Let me see hands when you got an idea. Let me see hands when you got an idea. Hands, you got a couple ideas. This is good. This is good. Ryan, what do you think?
I'd say more.
Why more?
Because when you win it, it will raise the average.
The idea is we have to raise the average. It's negative right now. The only way to raise the average is to make it less negative. That means we have to pay the player more to bring the average up. And if this is still the same as it is, these aren't changing, that's got to be higher in order to make the payout pay out. So we got a couple ways we can do this. A couple ways you can do this, friends. What's one way? Elena, you actually nailed it earlier. What did you say earlier?
before that, I saw, okay, 3 trials, right? 3
Yes.
or 4? 3
Mhm.
trials?
Well, you have 3 dice, so what?
3 dice.
3 dice,
So
yeah.
I would say, I would actually vote for 27. I don't know if I'm right or not.
Okay.
but 27, it's my
So
point.
you're saying 27 should be
At
that
least,
value right there.
at least,
Let's check it
yeah.
out. Let's try it. Let's
At
try
least,
it.
at
Well,
least,
at least,
at-
let's find it. Let's see if 27 works.
27 or 36.
Now,
I don't know.
let's see. Let's just see. Let me switch this over to here, and then this, and let's see if we can get,
And I know that.
this is on, I think. Maybe. Hey, there we are. Okay, so what I'm gonna do is, I'm gonna enter the distribution. I'm gonna enter this distribution that you guys just talked about. So what I'm gonna do is, I'm gonna, in L1 and L2, here's the original distribution. -1, 0, 1, 9. Those are my original payouts. Let me make this a little more centered for you guys. There we go. Okay, and the probabilities over here, crap. Haley, can you give them to me again, the PMX column?
Yeah, 0.580.
0.580,
0.343.
0.343,
0.073.
0.073.
0.005.
Thank you, my friend. I'm sorry I didn't mean to interrupt you guys. You guys had a
No,
discussion
that's
going. I
fine.
apologize. So here's how Haley. I know, it's all good. I love when you guys communicate with each other. I love this because you guys are telling each other things in a way I can't do it. So it's wonderful. It's wonderful. Here's how Haley got the -46 cents. Actually, you guys know this, right? You know how she got that. She ran one of our stats on L1 and L2. And there is your average right there of -46 cents. So that's how much on average we're losing. So we're losing on average. So basically, instead of going up and hanging $1 and asking to roll the dice, just walk up with 46 cents, hand it to the person behind the bar, and walk away. Because that's what's going to happen on average, right? That's what's going to happen, and it would save them a lot of work. Okay, so far? Now, the question is, we now have to mess. Oops, not that. That's not what I'm doing. We now have to mess with that value right there. So we have a vote for 27. Now, what this would mean would be actually 28 to 1 payouts, wouldn't it? Because the 27 there, we still bet $1 to play, correct?
Yeah.
Which means we're actually getting 28 bucks back, subtracting 1 for the ante. So we could, oh, actually I can just do this. One of our steps, L1, L2. Notice it's less negative now.
Then 36.
Notice it's less, you notice it's less negative? Check that out, friends. It's less negative, which means that we're losing a little less money per.
Yeah, I forgot about one.
So now we have a vote for 36. Let's see if this does the trick, huh? Less negative, but I don't want it less negative. I want it non-negative.
Yeah.
So,
More.
you guys see if you can figure out what it has to be. And while you're doing it, I'm going to race you using algebra. I'm going to race you using algebra.
I don't have my calculator yet.
What's that?
I don't have my calculator yet.
Oh, okay, I want you to get it in. Let's make it fair. Let's make it fair. I'll take my time. I'll work slowly.
Okay. Quite slowly.
Let's make it even, you said?
Say that. I want it fair, statistically fair, which means the average needs to be 0.
0. Okay.
Oh, if you guys need a distribution, here it is. Here's the distribution Haley gave me earlier. It's definitely important.
That's what
I love me some algebra. I love me some algebra. Uh-huh. Uh-huh.
we started that in class.
Ooh.
We finished it.
Oh, we did a lot. We did a few of them by hand in class, didn't we?
Uh-huh.
So this is negative plus positive. It's going to cancel. So we're going to get negative
Mother.
Wait, I'm too far.
7. I'm going slow, I promise.
You want it to 0?
I want it to 0. Get as close as you can. It probably won't work exactly.
That's what mathematics is. Oh, I'm so close. I know. It's so funny. So cool though. You look. Oh my god.
No, it's algebra. I know it's sometimes confused. It's sometimes confused with craziness.
I know.
I'm 1.9.
What do you mean, 104?
Oh, 101, not 100. 101.4. Sorry, 101. or 102. I'm sorry, I saw the 4 and I altered. Keep working, keep working, keep working. Kels, keep working. Are you playing on it?
Yeah, I got it.
Good, good. You beat me, didn't you? You beat me. You were done before I was.
I don't know.
I wasn't really trying to race you guys. That's not what I'm about here. It's not about racing. I'm going to pull this down so we can see. So give me your guys' thought process as you work through this. So we did 9, which didn't work. 27 wasn't big enough. 36 wasn't big enough. What did you guys go next? What did you guys go to next after 36?
45.
Say that again, 40?
45.
45? So then we do edit, we go to 45. Okay? Okay, so it's still less negative, but it's still not 0. So Jada, what'd you go to then?
Well, my calculator's broken, but
Oh.
right away I thought you need to go up to like 100.
Right away, Jada said, I gotta go to 100 because this is not getting less negative fast enough.
Yeah.
Think about it, friends. Think about it. We were paying 10 to 1 odds.
Oh,
10 to 1 odds had a negative 46. Now, this was, what did we put in now, 45? That's 46 to 1 odds. Those are ridiculous odds. But it's still negative. So Jada said, let's go straight to 100.
Yeah, because
Let's go
10
straight
is
to 100.
10 to,
Now, 100 actually is 100 to 1 odd, 101 to 1 odds, isn't it? Because this means we're clearing $100, which means the payout's actually 101 to 1.
Yeah.
So let's see how that comes out. Damn close, huh?
Yes.
It's damn close. I would accept $101 as a payout, of course. Of course. We put in 100 into that spot right there.
Because we 1 to 10, that's the thing, 9 to 10.
Well, yes, but the idea is there's a multiplication and an addition. So there's a linear relationship as well as a multiplicative one happening in here. And that's why I said I'm going to race you guys. Because here's what I think of. And this is because I'm diseased. So I'm going to mute this.
No, me too.
I tried 101.5 and it did like times 10 to the.
Good. Oh, Haley, hang on. She tried 101 and a half. 101 and a half. So you are getting 102 and a half to 1 odds. That's strange.
It's between, yeah, she's right.
That's strange, but look at that. That's $0.0005. It's slightly positive. It's slightly positive, but it still rounds to 0. So, Haley, what you essentially just found for us was the break-even point of the game. You found the break-even point, which agrees pretty much with what I got over here.
Oh.
Right? Now, here, how I did it algebraically. Let's come back to this.
And actually, Anne will tell us also the number of
Yeah,
10.
absolutely. So check this out. I didn't know, let's put this around here. I had no idea how much it had to be. No idea how much it had to be because I didn't have, when I do a problem like this, I don't start throwing values in like 36 and 27 because I don't think that way. I think to myself, okay, I have no idea how to do that much math in my head. And I would grow tired of trying to just kind of plug and chug. So I said, let's think about how you calculate an average of a distribution. Now you guys told me this. Hell, you actually alluded to it about 20 minutes ago. When I said, what does this sum to? You weren't looking at what I was pointing to. You heard the word sum and you said it's negative 46. Because you were remembering that the average, let me slide over here so you guys can see this. You were remembering that the average of a random variable, a discrete one anyway, is equal to the sum of each random variable's value times its payout. Excuse me, payout times probability.
Right.
So, and we've been doing this for weeks.
Yep.
That's just what kind of an average? What kind of an average is that? Say it, Jada, nice and loud, my friend. You just said it. Say it again. Weighted. It's a weighted average. You're weighting the data with the proper weights. It's just that the weights are now percentages. So all I did right here was I took each payout times its probability. You lose $1 58% of the time. Plus, you break even 34.3% of the time. Plus, you earn $1 7.3% of the time. Plus, I don't know how much we're going to earn. Question mark.
So it's like x equals.
Exactly. And that's what I set it up like this. Now, that whole equation has to equal 0 because I want it to be fair. The difference, Elena, was awesome. You noticed you saw like we did this last week. We did.
Yeah.
But last week, we had everything on this side.
We haven't finished.
We had everything on this side.
Yeah.
And we're just diluting it down to one value. Now, we know this side has to be 0, and we just got to solve for that. And this is where your algebra skills come in. So this cancels, that becomes 0, so that goes away. This is just negative 0.58. That's positive 7.3. They combine to make negative 5.507. Then you got this question mark times this. Move this over,
So
divide
there
it by
is a
that.
formula. Anyway, we can figure it out mathematically.
Use that.
Yep.
Use that, by all means. That gets the job done. Now, is there anything wrong with doing it the way you guys did it? No, not at all. It depends on what path you want to take. Do you want to take the trial and error path? I kind of like the trial and error path. I'm honest with you.
At least you can check if we're right.
Of course, well, that, but also you're coming to the solution kind of in your own way. You're saying, okay, I know it has to be higher, like Ryan said, it's got to be higher than a 10-to-1 payout. But how much higher? Then you're like 36, 45, 50. Holy crap, it's not getting big enough, fast enough. 100, boom, and then all of a sudden you're there. You're like, holy crap! Now think about this, friends. This means the break-even point is roughly 100-to-1 payout. Nobody pays 100-to-1 odds in Vegas, but here's what they can do. They usually pay 10-to-1 odds, right? On the big hit of 3 5s. They can come at you and go, we're going to raise the payout to 20-to-1 odds, double your payout. Holy crap! What's that going to do to attendance at the game? People are going to flock to the game and play more. Are they going to win anymore? Yes, but they're still going to lose on average. They go from losing 46 cents to losing 42 cents, which means Vegas has to accept 4 cents less per game, but they're probably getting twice as many games, which means they're making more money overall in the long run. Does that make sense? We're going to do a lot more of those kinds of analyses as we finish this course off, because that's really, in my opinion, that's the heart of this course, is seeing how to kind of process those finaglings in the inputs. Oh, no, thank you. This is a great question. This is a fantastic question. It's a fantastic question. And far too much algebra for an in-class exam, just so you know. Just put your yay, Jenny, yay. So, but a very, very important thing that we're going to come back to over and over again in this class with the remainder of time we have together. Make sense? Haley, ask me that question.
So pretty much if it's asking you, like, what would it have to be to make this 0, you just pretty much do it.
This is how I go about it, but you could also do it your way. You could just keep checking the numbers and see which ones work.
Well, I like the equations.
And this is, have you guys noticed how many formulas do we use on a regular basis in this class?
Like one.
I think I'm giving you the hint right here if I put this over my mouth as I'm thinking. I think well, actually, I'm going to say 2. Because we do fall back to the idea of the average quite a bit, sum and divide. But this is an average in itself, so technically it's an average formula. We don't use the standard deviation formula because we use technology to get that for us, because you guys know what it means now. We haven't used quartiles or IQR formula. I try to leave those out unless I think there's a value to them. And here I think there's a value to this, because I think it does save you time on average. No pun intended. Cool?
Yeah.
Does that make sense-ish?
Yep.
And now, Elena, I think what you said was 100% correct. Now E10 is approachable, now that you know what E9 is.
Yeah.
Now that you know what E9 looks like, E10 is definitely approachable. But there's nothing wrong with using just the plug and chug of 1-bar stats to get this result. There's nothing wrong with it at all. This is just a more direct way of getting to it.
You see, I actually, the first thing I did, in 2 ways. First, I assumed I do it and I did these numbers. Then, at 11 o'clock at night,
Your brain working on it.
And boom, and
Yeah.
I wrote down this, and I compared the same numbers.
It's so cool. Oh, yes, and that's wonderful, isn't it? It's this wonderful thing. I just like today, I got this pamphlet handed to me by my department chair, saying this is what some schools in California are doing for pre-stat, and they handed me. I'm going through this pamphlet. I'm like, this is exactly what I'm going to do here at COCC. It's validation. So when you can validate your own work, that's even better, right? That's even better. So good for you. So here's 2 ways. One way is going through and trialing and erroring. Here's another way. Pick your favorite. I'm not going to teach you guys algebra in 10 weeks or the 4 weeks that we have left together. Hell no. But pick your favorite. If you like the plug and chug, go
when
for
you
it.
said
It's
1
direct.
to 10, it's like boom. At least you can predict.
Exactly. You know where it has to go. It has to head this way.
And then already do whatever.
But you see, this is again, and this goes way past Vegas. This is what actuaries have to do when they're setting premium rates on insurance policies. We know that if we charge people $35 a month, we break even. So we have to charge them more than $35 a month in order to bring money in to pay salaries, to pay rent, to pay utilities, to pay into the pool. So this is the idea of finding this balance point, this idea of a break-even point on a random variable. Huge, way past Vegas. Although I really wanted to use that damn one-armed bandit from Vegas to use you guys in your exam.
This
Try it.
goes about any business.
It's any business has a break-even point, but this is very often, you guys may have seen this in your previous math classes like 95, where you would graph a function and find the break-even point where the profit equals 0.
Yeah.
That's totally rad. The problem with that is that was usually based on some kind of a fictitious model of the data. This is based on observed reality, like actually seeing what happened like we did when we held down F9 and watched the dice fall, or watched the sales come in. I mean, this is a little more realistic in that respect. Messier? Hell yeah, it's messy. It's messy as hell. But again, you now know 100 to 1 is roughly in the neighborhood of breaking even. So control that. Control that. Set it lower if you want to bring money in. Raise it up higher if you want to lose money. Everybody wants to lose money.
So what is the question exactly? Like what is it?
Let's go back and look at it, Haley, to revisit it. It started with a definition which we may have forgotten because we got kind of bogged down in making it equal 0. Then have to ask ourselves, why are we making it equal 0 again? So let's go back and look. Maybe. There we go. So this was the point right here. The point was, what should we pay out on 3 5s to make the game average to 0, not negative 46 cents? We wanted, here's the old average right here. I don't know if you can see that one, blank.